Hi folk, my name is Dr. Michael Grant and I'm the CTO of DataProphet. The AI system that we've built is incredibly descriptive of the process that sits below it. And through the introduction of some really exciting data science methods, we've been able to generate very sensible results that remain consistent without much data. So typically we look about 10x given the number of parameters that operate in your plant. So with 60 parameters, we need about 600 samples. A lot of folk that I chat to are quite concerned that the data that they're recording from their production systems may or may not be able to be used in these kind of opportunities, particularly around expert execution systems and the installation of them. I don't think it matters that much, and I'll tell you why. It turns out that we're able to handle most of the extract, transform and loading of your data into our EES system. And so the actual root format that your data is stored in on your production system doesn't matter as much as the fact that you're recording it. And that is the most important thing. Record your data, save it, make sure that you're not aggregating it, but don't worry about the underlying schema. It turns out that that isn't too important. When one operates in a reactive paradigm, having data as quick as possible from the result is super important. Because you're reactive, you've got to act on the change as quickly as possible. So you've had some defect occur, and every second that you wait, you're making more of the defect. And so a 2-second delay can result in thousands of components being made defectively. If you're operating in a prescriptive paradigm, you're actually ahead of real time. You're making some change in anticipation of a future risk. But because you make the change, that risk is never realized, and so you never incur the scrap or never incur the cost of non-quality. And so your entire process is sort of ahead of that wave of quality. Measuring the quality result of your production process is really important. Not just recording the fact that a defect has occurred on a specific component, but also what the type of defect it is, where it is located on the component, and any other descriptive details that may be appropriate to your domain. It turns out that being able to diagnose the root cause, and this is what our AI system does, but being able to diagnose the root cause is really dependent on having a good description of the type of defect that you've got. When we're installing our AI system, we build some models that describe your process. In fact, it's a very large monolithic model that's able to understand the dynamics from the start of your process to the end of your process. Sometimes we find in systems large sources of unexplained variance. And this is a signal to us that there is a sensor or there is a measurement in that part of the process that could be added that would then describe that process. And so we're able to give you very specific guidance that in this process there is a large source of unexplained variance, and we need to go and measure what it could be. We work with your engineering teams to identify the kind of dimensions we need to measure, be it some kind of process parameter or some improved logging and reporting.